Hello everyone, my name is Danny Phillips and I decided to do my presentation on magic methods in Python. Now I first came across this topic in ISTA 130, which is an introductory programming course that teaches Python here at the University of Arizona. In this class, I only learned base level concepts, but did go as far as object-oriented design, creating our own classes and objects and using them accordingly. In the class, we got to magic methods, and I was really curious about them, mostly because the name is incredibly interesting. And the instructor told us not to worry about it. It was a little bit too complex for the scope of the course, and we just moved on. So, when I saw this topic in the topic list for the video project, I thought, what better of a time will there ever be to explore this and share this with everyone? So, after researching it, I can assure you that you don't need to be a wizard, magician, and you certainly don't need to take any magic mushrooms in order to understand magic methods. I hope to solve the mystery for all of us right now. Before we get into this, I would like to thank Rafe Kettler, whose website is here, rafekettler.com. His website was the basis for most of my research regarding magic methods, and his website actually has a lot of helpful tips and tricks for Python in general. So if you're looking to take up Python and don't know where to start, his website is a great jumping point. So, what do magic methods look like? If you've worked in Python, you've likely seen one. They have two underscores both before and after the name. Here are two extremely common examples, init and new. These are called whenever you create an instance of an object in Python. So at this point, you're likely asking yourself what magic methods are. What exactly makes them magic? The fact is that magic methods are not invoked directly. This means that you don't have to call them. The most prominent examples of this are init and new, which I talked about in the previous slide. They are called automatically when a class is instantiated. We don't actually need to call the init method or the new method. They are called automatically whenever we create an instance of an object. This leads to a follow-up question of how exactly this works. How does Python see these methods and use them automatically? Unfortunately, I couldn't find much more behind-the-scenes information on this, and the documentation on magic methods is notoriously poor in Python. It appears that they just kind of work. So really, who knows exactly how they work? Thankfully, we don't really need to know. It's all done behind the scenes, which makes it extremely accessible by Python programmers. It's why they're called magic methods in the first place. Even some advanced Python programmers don't know how they work. They just work. And that's all we need to know. We just need to know how to use them. And it just goes ahead and it does its own thing behind the scenes. And it's perfect from a programming standpoint. So, this raises the important question. You're probably thinking to yourself, all right, Danny, you've taught me what magic methods are a little bit, what they look like, what they can do, then that's great and all. But why use them? So, here's why. Here's this big selling point on magic methods. They make user-made objects behave like built-in types. So to give you an example of what I'm trying to say here, is that in Java, for example, there are classes that are a part of the API, like string, for example, where you can use special operators to make code cleaner. But these operations are impossible on classes the programmer writes. They have to use other user-made methods. So for example, if we're looking at two strings in Java, and we're trying to check if one is equal to the other, we can say string 1 equals string 2, and we can check that value to determine whether or not they are equal. But if you try using that same operator on a class that you, the user, has made, it won't work. You have to make some kind of other method that checks that for you and call that method. However, with magic methods, using special operators is entirely possible on any object you might make. Here's a great example, the CMP method. Now CMP, as you might imagine, stands for compare. So, without CMP, and you've probably seen code like this before, if we have two instances of an object, one called instance, one called other instance, and we're trying to check if they're equal to one another, we could call instance.equals other instance. we have to call the equals method, and it will tell us whether or not they are equal. Now, most programmers can understand this code. It's relatively easy to read. However, with magic methods, we can make it even cleaner and even more easy to understand. We can say if instance equals other instance, and then handle it accordingly. It is a more direct representation of what the programmer means when they are writing their code. So, to wrap it up in a bow, we don't actually need magic methods, but we use them to make things easy. Easy to write, easy to read, and easy to think about. As a programmer in a career, you're more than likely going to need to look over somebody else's code and understand exactly what it means. And being able to do this with magic methods is far easier and far faster to understand. And this, with the CMP method, it doesn't just limit itself to equals equals. You can do less than or equal to, greater than, so on and so forth. It just makes things easier. Now, when you're writing your CMP method, you can define specifically what you are checking. For example, if you're cross-referencing two animals and two animal objects, and they have speed attributes, you can define in your CMP method that you are comparing the speed attributes specifically. So if one animal has a lower speed than another one, that can be what you are checking in your CMP method. So you define that for yourself, and then you can just use the operator itself in your program, and it just works. So, in conclusion, what I want you to pull away from this presentation is whether or not you believe that magic methods are truly worthwhile. Because, like I said, you don't actually need them. They're just a stylistic choice. However, I know that when I was going through and thinking about magic methods, I thought about how much easier it would make other languages. I really could have used that in Java when I was first learning programming. I could have used it in C, where my code was unreadable, borderline, for most of my programming career. And I probably would have done better on my Ruby projects in this course if I had something similar to Python magic methods. I hope that this presentation helped you learn a lot. I hope that this opens the avenue for you to explore more about magic methods on your own time. I will probably be trying to uncover the mystery of exactly how they work because I couldn't find anything on that. But yeah, I hope that this was eye-opening for you. I know it was a very cool and interesting topic for me to explore. Thank you so much. Have a good day.